Hey guys!
Hey.
Today we're going to talk about Chapter 7.4, not really.
Yeah.
Graphs of the tangent and cotangent functions.
Yeah, this really, graphs of the tangent actually shows up in 7.1. Cotangent actually shows up in 7.2, and 7.1, 2, 3, and 4 kind of do a bunch of junk, and so we just gave it the name 7.4 just to get the people that aren't doing, the people that aren't really watching the videos and the ones that are using their tutors instead of the videos to teach them. So.
Alright, so here we go. Whoops, sorry.
Whoopsie. Okay, so today we have not talked about tangent and cotangent. Now let's remember, sine and cosine have r in the denominator, and they have a range that restricts them between 1 and -1 because y and x are never bigger than r. Cosecant and secant, the reciprocals of sine and cosine respectively, have a range of bigger than 1, greater than or equal to 1, or less than or equal to -1. And that's because they're all the reciprocal values of sine and cosine. But tangent and cotangent have no r in the ratio, and they have x. And tangent can be written as, tangent can be written as sine over cosine, and tangent of an angle is y over x. Tangent of an angle. Tangent of y over x? That's not what you mean.
Oh my goodness.
Okay, once again, it's early, and now it's Ms. Miller making errors. Yay, tangent of theta is y over x. All right, but the more important, well, both of those are useful, okay, but there's clearly going to be some places where this function is not defined, specifically where x is 0. And where does x happen to be 0 on the unit circle? At pi over 2. 3 pi over 2. Hey, guess what? Pi over 2. Add pi to it, you're at 3 pi over 2. So now you just got a really important thing. The tangent has a period of pi. And in the words of Dr. Wiesner, the period is not 2 pi. Okay? So, the tangent has a period of pi. Why is that? In quadrant 1, we get all the positive values for tangent. In quadrant 2, we get all the negative values. And guess what? They repeat themselves in quadrants 3 and 4. If you look at the sine, you get positive values in quadrant 1, positive values in quadrant 2, negative values in quadrant 3, and negative values in quadrant 4. But when you compare the coordinates of the xy points, it takes a full revolution of the circle for every single pairing of positive x, positive y, positive x, negative y, etc. to match up. Same thing with cosine. In cosine of theta, you have positive, negative, negative, positive. It takes a full rotation for every pairing of positive and negative values of x and y to get matched up. Not with tangent and by the fact that we have a reciprocal cotangent. Cotangent and tangent get every pairing of positive x's and y's happening in 2 quadrants. Therefore, the period is pi. Now, critical points, we kind of have to have a little exclamation around points because when you have an asymptote, you don't really have a point, but it is an important place where something occurs. Our critical points are still found by taking the period of the function and dividing by 4. So, we're going to graph zeros and asymptotes, and halfway between the 0 and asymptote is your amplitude point, but you don't really have amplitude because you don't have maximums and minimums. You'll see. So if we look at this, again, we don't want to do every single one of these. Let's just do the ones that are super important. At 0, we're at the point x is 1, y is 0, so we're looking at the ratio 0 over 1, so tangent is 0. At pi over 2, we're at the point 0, 1. Okay, x is 0, y is 1, y over x is undefined. Well, you know what's really cool? Halfway between that is pi over 4, and pi over 4 is square root of 2 over 2, comma, square root of 2 over 2, and guess what? That ratio is 1. So we can come down here to pi. Pi is the point -1, 0. At -1, 0, I have 0 over -1, still 0. Halfway between that, 3 pi over 4. X is positive, y is negative. The numbers are the same, the signs are different, so we have -1. And look what happens when we come back down here to 3 pi over 2. 3 pi over 2 is 0, -1, undefined. 5 pi over 4, we're in quadrant 3. The x and y are the same. Oopsie, but they're not both positive. They're negative, negative, and that becomes a positive. And so you could pretty much tell what's going to happen here. This ought to be -1. Test it yourself. And look what happens when we graph it. For tangent on the origin, we have a 0. Pi units away is another 0. Pi units away from that is another 0. So if you use your brain, you probably can tell that pi units before that and pi units before that is zeros. Now, halfway between the zeros, from 0 to 0, we have a vertical asymptote. That is happening at pi over 2. And since the period is pi, we're going to have another vertical asymptote at 3 pi over 2, at -pi over 2, -3 pi over 2. And now we deal with that crazy thing called the amplitude point. See, now amplitude really has its proper meaning with sine and cosine because it's a wave, there's a maximum, there's a minimum. We use the idea of amplitude to graph cosecant and secant, although there's not really maximums and minimums per se. And this function really doesn't have maximums and minimums, but we use the amplitude by looking at the coefficient of this is 1. And that means halfway between our 0 and our asymptote, we go up to a value of 1. And if I recognize here at 3 pi over 4, I'm at -1. And then at 5 pi over 4, I'm at 1. Well, from this branch here, you can see what's happening. Well, you need to graph a few more points to get that, but we're lazy, we're not going to. So we can see that if I have a value of -1 there, I must have one here at -pi over 4. And now you can see here at -3 pi over 4. Well, let's remember, tangent's an odd function. So the tangent of -3 pi over 4 needs to equal the negative tangent of 3 pi over 4. 3 pi over 4, the tangent is -1, so tangent of -3 pi over 4 means we're at +1. And there you go, you can see that from here, from this point here to this point here, we have a period of pi. From here to here is a period of pi. We can go back. We can see then that at -7 pi over 4, we're going to be at 1 again. And you can see how this pattern is going to repeat itself. The -1 is going to happen here at -5 pi over 4. Again, using our odd property, the tangent of -5 pi over 4 needs to be the negative of tangent of 5 pi over 4. And if we come over here, tangent of 5 pi over 4 is +1. Here we are at -1. Now, oopsie, that was a really bad graph there. So I'm going to redo that part of it. Now, and we can see what's going to happen here. And you can see over here that it should do something like this. Now let's remember, the purpose of vertical asymptotes is to tell us where functions are not defined. So we would never cross a vertical asymptote, and we also would never curve away from a vertical asymptote like that graph does. So we need to get closer to that asymptote, but never touch it. Okay? And when we graph the cotangent graph in a minute, we're going to look at
where this one's 0.
Yeah, where this one is increasing, cotangent needs to be decreasing, because that's what reciprocal graphs do. Think about your sine function. Where a sine function was increasing, the cosecant was decreasing. So you can see that this is increasing on this, oopsie, this is increasing on its whole interval. See that? Except for where it's undefined. So that should give you a precursor to when we graph cotangent, it should be decreasing the whole way. Now, I have a very stupid way to remember which way tangent goes, because my students in the past usually have trouble remembering does it go up or down. Think about, this is stupid, to the angels. We're going to fly up to the angels. Okay, so your tangent graph goes up to heaven if you read a graph from left to right. It's kind of stupid, but when we get to the one for cotangent, you'll remember it. All right, now I am going to redraw this graph. So on your notes, don't redraw what we just did. We're going to redraw the tangent graphs just so we have something to look at. Okay, 0 at the origin. Undefined at pi over 2 and negative pi over 2. So you can see we can plot our zeros. They're pi units away from each other. Our vertical asymptotes are pi units away. And tangent of pi over 4 is 1, and tangent of negative pi over 4 is negative 1. And that gives you your first sequence, and now you have everything you need to graph, to sketch our graph. We're having a good time.
La la la! Graphing cotangent. I mean tangent.
Oops, yeah, not so.
The reciprocal of cotangent.
Yeah.
I don't know, we'll make up a song.
Yeah.
Making up song, a graph in the morning.
She's difficult. Love her. Difficult. Okay, so here we are.
No, I'm silly. That's the word you're looking for.
That's true. If we talked about difficult, we'd have to start naming some students. Okay, we want to find where the tangent of t is 1. This is like setting up an equation. Find all values where tangent of t is 1. Gee, Ms. Miller, could you circle all the places where the tangent has a value of 1?
Right there. Right there. Right there. Right there. Right there. Oh, I need to go off the board. Right there. Right there.
Yeah.
Every pi unit away.
So where would be a good place to start?
How about that one? Because it's nice and in the first quadrant.
And so if we go here, that's plus pi. And do it again, that's plus another pi. And if we come here this way, it's minus a pi. So what do you think our way of finding that is going to be? T equals pi over 2.
Pi over
4. Plus
minus
pi k, where k is an integer. You know, frankly, you don't need the plus minus, because if k is an integer, k could be negative, but we'll just leave the plus minus. It points it out. Okay, now, let's look at this. Again, silly, stupid way to remember. Tangent goes up to the angels, to infinity and beyond, right? Like in the words of Buzz Lightyear. Now let's look at cotangent. Oopsie crud. We can't look at cotangent yet. I forgot about this graph. So now we're going to look at the tangent graph.
Shift it down 2 units.
So what was the first thing we do?
So first thing we need to redraw the.
Let's just do the shift. Let's do the vertical shift.
That's what I was going to do. Redraw the vertical.
Oh yeah. I thought she was going to redraw.
Redraw the axis here.
Okay, so we're moving
the
0 axis down.
It's not really sinusoidal because
this is not sinusoidal.
Tangential.
Yes, tangential. Tangential as
I'll come up
opposed
with
to tan
weird,
harsh.
strange words here.
So notice there's not a shift to the right or the left. Shift, I said. There's not a shift to the right or the left. There's just a vertical shift. So all we're doing is taking the graph we had on the previous page and shifting it down 2. Now, if we look at this, okay, we can use our amplitude point, and we know at pi over 4, if we're shifting it down 2, we know that our branch should look like this. Okay, and while Ms. Miller is doing that, what I'm going to do, can we write at the same time? I know we can't do different colors.
No, we can't write at the same
Okay,
time.
go.
We don't have a cool board like Mr. Coach Wilson has a really, or Mr. Wilson, Colonel Wilson has a really cool board that you can do that.
Really?
Yeah, that's the new boards.
Oh, darn it. We don't get the new boards when we move.
Well, that's okay. We'll make do.
Okay. All right, so as you can see, this shouldn't be a problem. You can see how the shift is. So we haven't changed anything but the shift. And notice that what we're going to do, I want to show you one thing, just kind of, we're getting you ready for when we start solving equations, which is coming up. Okay? And notice that Ms. Miller is just putting the increment place of where the values are, but what we expect you to do is on the axis is to write your pi over 4, negative pi over 4, all that. We're not letting you off of that. you have to write all those points, okay? But we want to move on to other things, actually, right there.
Oh.
It's all right. I did the same.
Oh, I got excited.
Yeah, I know.
This is 5 pi over 4 anyway.
Okay, you get the point. But I want to talk about something before we move on, and that is this. So what is h of pi over 4, okay? Well, h of pi over 4, according to this, says we're going to take the tangent of pi over 4 and subtract 2. Now, at pi over 4, we know we're looking that, and we know our y value and our x value for our ratio are the same, so we know that that is 1. And 1 minus 2 is negative 1. So for this graph, h of pi over 4 should be negative 1, and what do you know? There it is. So all these things you've been learning about equations all year long still come into play. Now we're ready to graph cotangent. Look at the graph of tangent. I'm going to go back. Here's the graph of tangent. What is going to happen? Cotangent is reciprocal of tangent. So what's going to happen? Everywhere that we have a 0, we're going to get what?
A vertical asymptote.
And every place we have a vertical asymptote, we're going to get
a 0.
And now the other element is that when you look at reciprocal graphs, where one function is increasing, the reciprocal will decrease. So remember, tangents are floating up to the angles, T-A-N, 2 angels. Oh, poo. Here's your ET problem. Good. Do that one. Have fun. All right. Cotangent. Here's the stupid memory. Crash on tummy. Crash. Crash on tummy. Crash on tummy. Okay, we're colliding to the earth. We're going to crash on the tummy. The angels go up to heaven, float up to heaven, and cotangent, crash on tummy. Crash on tummy. All right, so we had a 0 on the tangent graph on the axis, and so this will be an undefined. We had a 0 at pi. This will be undefined. Uh-oh, that was a bad one. That's a bad one, but you get the point. Our zeros are where the vertical asymptotes were in the previous graph. Our amplitude points are at pi over 4 is at 1, 3 pi over 4. Why is that one at 1? Well, the tangent of pi over 4 is 1, and cotangent is reciprocal, correct? So we have to talk about the reciprocal of 1, and the reciprocal of 1 is still 1. Okay? And the tangent of 3 pi over 4 is negative 1, and guess what? Cotangent is also negative 1, and boom, here we go. See? Crash on tummy. So that's a general idea on that. Now, as Ms. Meller is finishing the graph, we'll talk about what's in the paragraph before this. Let's remember, cotangent is cosine over sine. So there are going to be places where the cotangent is undefined, and that's going to be everywhere where y is 0. Where y is 0. And y is 0 at 0, pi, 2 pi, 3 pi, etc. Okay? Again, tangent, since it's the reciprocal of cotangent, since it's the reciprocal of tangent, has a period of pi. And what would be the words of Dr. Wiesner?
The period is not 2 pi. One thing I wanted to show you guys is I wanted to take the tangent graph and I wanted to show you the superimposed version. Let me see if I can get it over there. Oh, come on. I wanted to superimpose it really fast. Okay. On, well, let me create a graph. Order group. Where's group? Grouping, group.
Or we could just draw the tangent graph on
Oh, but it's so much faster this way.
Okay. Doesn't look faster to me.
Oh, there we go. Okay. La 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 la. Is this not it? Not it? Yes, it. Okay. Paste it. Oh, well.
It's not transparent.
It's not transparent. Pooey. Okay, but whoa. Hey, something happened. Wait. No, that was good. Cause look, now okay, maybe not.
The group.
It ungrouped it. That is really strange.
Yeah. Can we just undo it?
It will go away. There we go.
If we look at the graph of tangent, I'm going to just do it in green. Oh, my goodness.
Oh, my goodness. It's just going crazy. The idea was a good one. Don't press anything. What is it doing?
Going.
Okay. There.
Don't press anything. No,
Now,
right?
now we're going. Now we're good.
All right. So we can look at the graph of tangent, and I'm just going to do it in green. So there's our reciprocal. Here we had 0. I'm just going to do one branch. The reciprocal of -1 is 1. The reciprocal of 0 is undefined. So the reciprocal of undefined is 0. The reciprocal of 1 is 1. This was 0 right here on the cotangent, which makes it a vertical asymptote on tangent. Likewise over here. And here is the tangent graph. One branch. Okay, so if you look at the green, okay, notice tangent's increasing in that interval, and cotangent is decreasing here, and it's decreasing here. Of course, it's undefined there. It's not continuous on that interval for cotangent.
Okay, so that's what it's kind of cool to look at it from that perspective. You don't have to write that on your graph.
Right. I'm going to
Please
erase
don't.
it now, and you can, if you want to draw it on your own paper, you can. But we're going to take it off so that this, if you come back to this, you want it to look okay. Okay. Okay.
Oh boy!
Yeah, this is hard. Okay, this is the last example we have. So let's list our A, B, C, and D. A is -4. Now that means instead of going, first of all, we're graphing cotangent. And what does cotangent do?
Crash on Tommy.
So sketch a little, it does that, but is this graph going to do that?
No, because it's negative, so you've got to flip it across the x-axis.
So instead of decreasing, this one's going to go up. It's going to look kind of like the tangent graph. All right? We say instead of going to 1 and -1, guess what? It's going to go to 4 and -4. So our amplitude points, even though there's not amplitude, so I kind of put that in quotation marks, our amplitude is not really amplitude, but it's 4 and -4. B, well, the coefficient of our t up there is 1. Okay? C, remember it is t minus c. So since that is a positive pi over 2, it was actually a minus a negative, and our d is -1. So going through our order of things we want to do, we're going to first of all do our vertical shift. So shifting the horizontal 0 axis. Okay, next is we're going to do our horizontal shift. We're shifting to the left pi over 2.
So that's
Now, what are we shifting? Are we shifting a 0 or an asymptote? Well, we're doing the cotangent graph. And here's the important thing to pay attention to on cotangent. When we're graphing cotangent, we are shifting an asymptote. If you are shifting a tangent graph, you're shifting a 0. So when we say what are we shifting, this right here would be on the y-axis, so to speak. So that's what's going to get shifted. So whatever is on the y-axis is what gets moved on the shift. All right, so since we're shifting it, let's draw a much better vertical asymptote. Since this dotted line represents shifting the y-axis, let's actually draw.
So I'm going to do this in a different color. Now, one thing about graphing in different colors, I find it very helpful. Honestly, on the test, and Ms. Darkstater thinks it's very helpful, on the test, you will be allowed to use colored pens and pencils to be able to graph these things if you so desire. Okay, so don't be afraid to bring them to class. In fact, we encourage you to bring colored pencils and things, pens, whatever, to class so that you can graph these that way. You can graph it in pencil and regraph it in pen or whatever you want to do so that you can erase it. I'll even make extra copies. If we mess up, we have that. So just FYI.
And period is pi, and we didn't say this, but I should have said this earlier. Your period, you know how to find the period in sine and cosine? Sine and cosine and their reciprocals was 2 pi over b. This is going to be pi over b. All right? Now, because it gets very complicated when b is a number besides 1, for the purposes of your learning how to graph tangent and cotangent, we're really not going to venture too far away from 1. I might have something where there's a 1/2 or a 2, but we're not going to do much more crazy stuff than that. But you do need to know your period is pi over b. Critical points are still period divide by 4. So in this case, it's pi over 4, but period divide by 4 is your critical points, and so for this one, it's pi over 4 since our period is pi. Okay? So period is pi means the next vertical asymptote is pi units away, and the next vertical asymptote is pi units away, and the previous vertical asymptote is pi units away. Halfway
zeros are still zeros.
Halfway between the asymptotes. Oh, Ms. Mellor picked up a blue pen, so now my green pen is blue. Okay, and just remember, tangent at pi over 4 is 1. Oh, but we have a shift. First of all, we have a vertical shift.
Oh,
silly me. See?
didn't graph them on the
vertical shift. So go erase your paper if you did that. Ha 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 ha. Okay.
All right, and then we had the change. We're now going negative, and instead of going from 1 up and 1 down the axis, we're going up and down 4.
4 units.
4 units. So that means that instead of going, this is, okay, pi over 4, originally we were at 1, but now we're going to negate it, so that would be -1, and then we have to go, instead of -1, we're -4. So
down 4 from
1,
that.
2, 3, 4. So at -5. Right there. And then up here it would be positive
add
3. 1, 2, 3. Let's see.
1,
2, 3, 4 away from the axis.
At 3.
At 3. And I'm going to put a 1 here.
Yeah. And so
and
one branch.
-1.
One branch of this looks like, oh, but wait. What's the mistake here? We're graphing negative cotangent. Actually, what we need to think about is this. Cotangent, hold on a minute.
That's right.
Negative cotangent should be going up.
Did I?
Yeah.
Oh, I didn't flip. I flipped it too many times.
Yeah, yeah. Negative cotangent. Cotangent.
It was originally there.
It should
and now
be,
we're going to flip it down, so it should be at -5 down here and 3 up here. There we go. Now we flipped it.
Yeah. So first of all, the flip was cotangent at pi over 4 should have flipped to 1. But then we go down to -1, and from there we move up 4.
Yeah.
Okay? Cotangent of negative pi over 4 is 1. Okay? But that gets flipped to -1, and then we go down 4.
Yeah.
Okay? And now this branch looks like this. The easy thing to remember is if you flip a cotangent, it kind of looks like a tangent. But your zeros and asymptotes are in a different place. Asymptotes. And you know what's so funny? Look at this graph. This graph looks like the tangent graph just moved down 1 unit, doesn't it?
And squished up, kind of skinny-like.
Yeah.
I mean, it's stretched vertically.
Yeah. It's going to look more liney-like. It's not going to have as much curvature. So that means that if we had, say, a 1/2 there, it would flatten out a lot more.
Yeah.
Okay?
All right.
So the thing to remember is, if you got confused on the negative part of that, let's remember cotangent should crash on tummy. So if you're graphing a negative cotangent, it should go up to the angels. Okay?
Okay, here's yours. A lot better than ours. Or a lot easier than ours, I think.
Yeah.
This one's not going to be so bad.
Shifted 2 cotangent t plus 3.
All right, so go ahead and do these things. One new thing you learned, be specific, and it better have something to do with this lesson.
This video.
1 good question and 2 old skills that are important to recall for this material. Okie dokies. Have a nice day. All right.
Bye.
Bye.
Did we record all that?
Oh,
I don't remember.
We're still.
Pressing record.
I did press record.
Okay, good. I don't remember it.
It's still stop recording.
That's good.